Part 2 in ellipses. When is a circle in perspective not an ellipse? Let's go back to the very first figure in the book, figure 1.1. It shows the picture plane, the viewer, the station point, the object being drawn, and the visual pyramid. They call it a visual pyramid because if you're drawing something that is rectangular and you project the corners to the eye, then you get a pyramid shape. If this thing that you are drawing is a circle and you project this to the eye, then you get a cone. Conical sections can be broken down into 4 things. If you cut a cone at a 90-degree angle, you get a circle. So in this situation, if you were looking straight ahead and you had a circle right in front of you, you would see it as a true circle. It would look like this. But if you looked at it from an angle, anything other than being like right in front of you, what you see is an ellipse. There are 2 other possibilities. So here's some cones. If we took this and we sliced it at a right angle, you would see a circle, a true circle. If we cut this cone at an angle, then the shape that you see is an ellipse. If we cut it at an oblique angle like this, it would not be an ellipse. These would keep going forever. This is a parabola. And if you cut it vertically like this, the shape is a little bit different from a parabola. This is a hyperbola, where if you take a mirror of the cone, then the cross section here will come up and be the same cross section up here. This one will not hit. If I put another cone on top of it, this angle does not hit the mirrored cone on top. So these are a little bit different shapes. We really don't want to get into the mathematics of conical sections. It's a drawing video. So we want to just know how to draw these shapes. So where you would run into these is if you had a very big circle and the viewer was inside the circle. Then you would have a parabola or a hyperbola. So again, here, if this was directly in front of you, then you have a 90-degree cross-section of a cone. It's just going to be a circle. Here, you have an oblique cross-section of a cone. So this would be an ellipse. If this person was standing on a circle, the shape that you would draw would be a parabola or a hyperbola. But I'm not so interested in defining the difference between those 2 in my drawing. All I need to know is how do I draw that shape? If a person's standing here or here or here, what shape am I going to draw that would represent that in perspective? So here's the circle, and we're going to put the viewer inside the circle and then draw the shape that you'd see. Page 98 is dedicated to this. We're showing the cross sections of this cone and the shape that you see in perspective. and here is a parabola. And this is a shape that would be drawn in perspective. If you look where this is, look at the cone of vision, this whole thing is outside the cone of vision. So, I mean, that's an issue you have to consider when drawing these shapes, when the viewer is inside a circle. Say it could be like a stadium, something like that, where the viewer is in the stands, or the viewer's on the field and the stadium is round. You're not going to be seeing a lot of the stadium. So first let's see how big this circle is. The circle's 5, a 5-unit circle. Let's put the picture plane 1 unit in front of the end of this circle. So here's our picture plane. And we're going to make the viewer 3 units behind the picture plane. But let's make them not right in the middle of the circle. Let's make them 1 unit to the right of the circle. So here's our viewer. This is our station point. Now let's give this a try. Here's our diagram. I made the viewer 3 units from the picture plane. The eye level is 2 units above the ground plane. So the first thing I'm going to do is figure out these 2 points. So this is 5, and the viewer's over to the right 1 unit. So we'll have 3 units on this side and 2 units on this side. Two units to the right, 3 units to the left, and here's the width of that square. So when you're drawing circles in perspective, you always are starting with a square. And we decided that it is 1 unit behind the picture plane. 1 unit back. So here's our measuring points for 1 point perspective. I'll come over 1 unit and go to the measuring point. And there is the back of my square. The middle of this 5-unit square is right there, 2.5. So there's one of the points. That point is that point. Now let's find the middle. We can do that by drawing 45-degree angle lines. We've got this tangent going on, goes right through the station point. So here is the middle of this square. That means we have these 2 points where the circle touches. Now we have these. It would be nice to have more points than just these 2. These 2 connect. But if we could do at least 1 or 2 more, let's do 2 more points. We didn't talk about how to do this earlier in the chapter. So let's draw an X through this point. And I am going to draw a horizontal line, or line that goes back in space. This is a 1-point perspective line. And it crosses the circle here and here. We're going to find these 2 points. So I'm going to do the same procedure on my perspective square. There's the middle. I draw a line straight across and a 1-point perspective line. Somewhere along this line and this line are points of that curve. I just need to find a cross section. If I draw a vertical line, and a horizontal line, they meet right there. Let's measure this distance. Okay, so we take that distance. We come over here to the measuring line. We put it here. This is the only place you could measure along this measuring line, along the picture plane. So I'm going to take that and bring this back to the diagonal line. I'm finding that point and then just straight across until it hits the purple line. Okay. So now I found this point and I found that point. That would be this point and that point. Another way to find multiple points along the circle. And then connect them. A nice French curve would be helpful, but you can see that the shape that's coming along here. This is not an ellipse. See, from here, this goes to infinity. And so I could repeat that procedure to the other side. Now, if you look at this diagram, you see the cone of vision. This is not even inside the cone of vision. But you could probably push the cone of vision. The cone of vision is not a rule that you cannot go beyond it. So if you could probably come out a little bit if you wanted to make your visual area a little bit wider. So here's what's going on with this. So here's our viewer in the picture plane. You can take things that are behind the picture plane. I just did a little cross section here along the picture plane. You can take things that are behind the picture plane and project them to this piece of glass. And you can take things that are in front of the picture plane and project them to the piece of glass. Things that are touching this picture plane are actual size. If you had something here, you will never be able to project it to the picture plane. If you look where the line of sight is, this line, this is going parallel with this picture plane, and it will never hit it. This is just going to infinity. If the person is standing inside a circle, anything in front of this line can theoretically be plotted. When it hits here, you cannot plot this. It's just, it will go to infinity. So that's where this comes in. A cross section of this will just keep going. It'll never hit this side. You can extend this cone out forever, and if you take a cross section of it at an angle that is equivalent to this angle, that is parallel to this angle, you can see that it will never hit this. It will go forever. So that's what happens when you're inside a circle. And there are a lot of different ways to plot circles. This is just one of them that we really didn't talk about, which is projecting points along the circle, projecting them out to the square, finding a cross section of two lines will give you a point. That's one way to do it. But if you're inside the circle, you are not really going to see much of that circle unless you push way outside the cone of vision. And if you did that and you wanted to show that really distorted section of a circle, it would look like that. You can see that these 45-degree angle lines, they will never hit this line.